Okay, so this is a set of information on rotations. So rotations is one of the forms of transformations that we're studying in this course. We have so far seen reflections or flips, translations or slides. So rotations are also known as sometimes turns. Right? So that one's an R. Turns. All right. So typically when we do a rotation, we're going to take a point, we'll call it P, and we're going to rotate it around another point, which I'm going to call O. This is sometimes referred to as the center of the rotation. And we do this so that this distance is preserved, but the point ends up somewhere else. So we're going to call that P prime. So we're literally moving it around O as the center from one place to another in such a way that the angle measure is preserved. So if you look, OP has to be equal to OP prime. And then this is going to be some sort of degree measure. So the measure of angle POP prime is X. So we're rotating it X degrees about the point O, would take me from P to P prime. Now, there's a convention that's used here, and it has a lot of logic behind it, but when we use the rotation as a positive, we are saying that we are rotating counterclockwise. So if I, let's say, rotated 30 degrees, so let's say that this was a 30-degree rotation, I am going counterclockwise. If I describe the rotation as negative, that is a clockwise rotation. So if I said that I rotated negative 30 degrees, that would have been the other direction. Okay, so that would have been this way. So this is the negative direction. This is the positive direction. Positive is counterclockwise. Negative is clockwise. Note that if I have a center of rotation and I take a line segment, right? So I'm going to take that here and I'm going to rotate it this direction. So I'm going to get another line segment over here. So I've now rotated this segment, right? So this could be the segment AB. It is now rotated in a positive direction to A prime, B prime. So like the direction of the segment has changed. I mean, it used to be laying this way. Now it's running this way. So the direction that the segment is facing has changed, but its length has not changed. So the segment's length is staying the same. So a transformation that preserves the length of a segment is an isometry. So this means that rotations are isometries. The length of the segment stays the same for any segment that is rotated. So a quick summary: a rotation has a center and a measure, and if it's a positive measure, it is a counterclockwise rotation about the center. If it is a negative measure, it is a clockwise rotation about the center. And ultimately, rotations there we go, are isometries because they preserve the length of segments. So when a segment is rotated, it does not change its length. So this is what makes the rotation in isometry. All right, thank you.